We will now begin section 1.8 and discuss rational and radical equations. We'll begin with a definition for a rational expression. A rational expression is an expression that can be written as a ratio of two polynomials, meaning it can be written as a fraction, p over q. Of course, such a fraction is undefined for any value of the variable for which q is equal to 0, because remember that when you have a fraction, you cannot have 0 in the denominator of the fraction. A rational expression is simplified or reduced when p and q have no common factors other than 1 or negative 1. Our first example asks us to simplify the following rational expressions and indicate values of the variable that must be excluded. So our first example is x cubed minus 8 divided by x squared minus 2x. So remember that x cubed minus 8 is a special factoring property that is the difference of two cubes. So recall that we could write this as x to the third minus 2 to the third, and use x and 2 to factor according to our rule for the difference of two cubes. So in doing so, the numerator factors into x minus 2, and then x squared plus 2x plus 4. When I look at the denominator of the fraction, I notice that there's a common factor to both the x squared and the 2x. So I can pull out an x out of both of those terms. So x times x to make x squared, and x times negative 2 to make negative 2x. Once our rational expression is completely factored, we can see that the x minus 2 is a common term in both the top and the bottom of the fraction, and so it can be canceled out. Which leaves our final answer as x squared plus 2x plus 4 divided by x. And so that is our rational expression simplified. It also asks me to exclude any values, or to note any values that have to be excluded. So the values that have to be excluded would be values that cause the denominator of the original fraction to equal 0. So we want to be careful here, because it's not the simplified form that we want to look at, but we want to go back to the original function. So in the original function, what would make the denominator equal to 0? And we can see that this, as we have it factored, we can see that x cannot equal 0, because if it equaled 0, we would have a 0 right here. And x cannot equal 2, because if we plugged a 2 into this one, it would cause a 0 factor. And so we will say that x cannot equal 0 and cannot equal 2. And again, to determine what values must be excluded, you must refer back to the original function, not the simplified form. So now let's look at part B of this problem. We have x squared minus x minus 6 divided by 3 minus x. And so we assume that the numerator of the fraction can be factored into two sets of parentheses. We know first times first has to make x squared, so it would have to be an x and an x. And the last two terms have to make a 6, so we could have 6 times 1, or we could have 3 times 2. We need something that's going to simplify to give me negative 1. So 3 and 2 would be the best choice. We need that term in the middle to be a negative, which means that the larger one, the 3 or the 2, the larger one needs to be negative. The smaller one needs to be positive. Now, if I look at my denominator, I notice that we are very close to having a term that will cancel. Here we have an x minus 3, here we have a 3 minus x. And so we can't cancel them quite yet, but what I can do is take that denominator and I can factor out a negative 1. So let's look at what happens when I do that. If I pull a negative 1 out of a positive 3, I'm asking myself, negative 1 times what to make positive 3? that would have to be -3. -1 times -3 makes +3. And then -1 times what makes -x? That would be a +x. And so if I take this term right here and turn it around, so I'm going to leave the top part as it is. I'm going to leave my -1, but instead of writing -3 plus x, I'm going to write x plus a -3 or -3. Then I can see that I can now factor and cancel those x minus 3's. And so my final result here would be an x plus 2 on the top over a -1. All right, and we're going to go ahead and sort of distribute that -1 through that parenthesis because we know that we can bring it up to the front very easily there and distribute. So we would have -x minus 2 as our simplified form of our rational expression. Now, what number needs to be excluded? Remember, we're going back to the original problem and we're looking at the denominator. So what number cannot go into that denominator because it would cause the denominator to equal 0? Right, so we need to exclude 3. And so we have our simplified rational equation, and we have excluded 3 from the possible x values. Okay, the next thing that we're going to look at is we're going to look at some basic operations with our rational expressions. In this first example, we're going to look at addition and subtraction. So in order to add and subtract fractions, we know that they need to have a common denominator. So our first example is 2x minus 1 divided by x squared plus x minus 2 minus 2x over x squared minus 4. So what I'm going to do here is I am going to go ahead and factor both of the both of the denominators in my original problem. So I'm going to leave the 2x minus 1, and I'm going to factor. So we'll factor that denominator. And so x squared plus x minus 2 will factor into an x and an x, making the x squared. For the 2, we'll need a 2 and a 1. We need our middle term to be a +1, so we're going to put a positive on the bigger term and a negative on the smaller term. So the bottom will factor into x plus 2 times x minus 1. All right, let's look at our second term. We're going to leave the 2x on the top, and we're going to factor the bottom. X squared minus 4 we know is the difference of 2 squares. So it'll factor into x minus 2, x plus 2. Okay, so now we need a common denominator between our two fractions. So we're going to do the least common multiple of the denominators. So we're going to look for the smallest things that they kind of have in common. Remember, we can always do the product of the two denominators, but we don't want to repeat anything. All right, so our new denominator, I'm just going to kind of make myself a note, and then we're going to work on this. All right, so my new denominator will need to be x plus 2 times x minus 1 times x minus 2, and I don't need to repeat that one because it's already there. So I'm basically just merging those denominators together, and that's going to be the new denominator that we're going to use. All right, so let's get this worked out. So I am going to take my first fraction, which is 2x minus 1 over x plus 2 times x minus 1. And I'm going to compare my current denominator to the new one, and I'm going to look for the difference. So I have the x plus 2, I have the x minus 1, I don't have the x minus 2. So I am going to multiply this by x minus 2, and if I do it to the bottom, I need to do it to the top. All right, so that's going to take care of the first fraction. All right, so the second fraction, we have 2x over x minus 2 times x plus 2. And again, we'll compare it to the new denominator and look for what's missing. So when I compare it, I have the x minus 2, I have the x plus 2, but I don't have the x minus 1. So I'm going to multiply it on top and bottom. All right, so now we're going to do some simplifying here. So I'm going to go ahead and multiply on the top. We're going to be doing FOIL method here on the top. So we're going to multiply the 2x minus 1 times the x minus 2. And I'm going to make a little space here now that we've got that done. Get rid of that, and so we've got some room to work. All right, so I'm going to actually come up here. All right, so when we FOIL it out, we're going to have 2x squared. Outside we make negative 4x. Inside we make negative 1x. And last would make positive 2. And that is over. And I'm not going to multiply on the bottom unless I see a reason to do that later. Okay, we're going to multiply the second set. So the 2x times the x minus 1, which is basically distributing the 2x through that parenthesis. So I'm going to get 2x squared minus 2x. And again, I'm going to leave my denominator, and I'm going to put it in the same order as the first one. But I'm going to leave my denominator unmultiplied unless I see a reason down the line to multiply it out. Okay, now my goal here is to combine some stuff on the top. So let's see if we can do that. We want to keep in mind that this negative is going to get distributed to both of those terms. All right, so let's see what we've got. We have a 2x squared and we have a minus 2x squared. That's going to be gone. All right, I have a negative 4x, and be careful here, we have a minus and negative, so that's going to be a positive 2x. So a negative 4x and a positive 2x is going to be a negative 2x. And I didn't see this before, but we also have a negative 1x. So combining that's going to give me a negative 3x. So I don't know, maybe that's a little confusing. Let me try that one more time with you. Let's just be sure we got this. All right, so we have a negative 4x. We have a negative 1x. And we have minus... We're distributing that minus to the negative 2x. So this becomes plus a positive. So we have negative 4, negative 1, and positive 2. That's going to make negative 3x. All right, so negative 3x. And that has now taken care of all of those terms. And then we have a plus 2. And we have it over x plus 2, x minus 1, and x minus 2. And this is our simplified version of our rational expressions added together. All right, so let's move on and look at part B. Okay, part B. We need to do the same thing. We need to come in and we need to factor everything that we can factor. All right, so let's see what we've got here. The first fraction is probably going to have to stay as it is. We have x plus 1 over x plus 3. Not a lot I can do with that one. Our second fraction, x squared plus x minus 2 on the top, I'm going to try to factor that. And x squared minus x minus 6 on the bottom, I'm going to try to factor that. Okay, so let's see. On the top, to make x squared, we're going to do x and x. To make this negative 2, we're going to do 2 and 1. In the middle, we need a positive x, so we're going to make the 2 positive and the 1 negative. On the bottom, we'll do x and x. To make the 6, we can do 6 and 1 or 3 and 2, but we do need it to combine to give me a 1. So that means that we're going to go with the 3 and the 2. We need our term to be negative. So we need the bigger one to be negative and the smaller one to be positive. So right now I'm looking at this thinking, okay, the x plus 2's are going to cancel out. So that's going to help me a little bit there. the 9, this one, the x squared minus 2x plus 9, that's not going to factor. There's no way to combine two factors of 9 and make 2, right? The only way we can make 9 are 3 and 3 and 9 and 1, and none of that combines to make 2. So I am just going to leave that one as is, x squared minus 2x plus 9. But the denominator does factor into the difference of two squares, so x minus 3x plus 3. Okay, so next up, we need a common denominator. So what does that common denominator need to be? It needs to be the product of our denominators with no repeats. So definitely an x plus 3, definitely an x minus 3. We've already canceled that x plus 2, so that one's gone. Here's an x minus 3, we've already got it. Here's an x plus 3, we've already got it. Okay, so our new denominator will just be x plus 3 times x minus 3. All right, so let's take these fractions and let's get them with the right denominator. So our first one, we have x plus 1 and x plus 3 on the bottom. We need to have an x minus 3 on the bottom. So I'm going to multiply the denominator by x minus 3. Remember, if you do it on the bottom, you need to do it on the top. Okay, so that's going to take care of the first one. Our second fraction, we have x minus 1 over x minus 3. So what else do we need for the bottom? We need an x plus 3. So we're going to multiply top and bottom by x plus 3. Our last one is fine the way it is. And so we're just going to rewrite it, x squared minus 2x plus 9 over x minus 3x plus 3. And now we're going to start doing some multiplying. Remember that we're not going to multiply the denominator, the bottom, unless we think it's necessary. So we're really just going to work on the top. All right, so x minus 1 times x minus 3 is going to give me x squared minus 3x plus 1x minus 3. I'm just going through our FOIL method there. On the second one, we've got x squared plus 3x minus 1x minus 3. The third one, I'm going to go ahead and distribute this negative. It's just going to make things a little bit easier to do that. So minus x squared plus 2x minus 9. And since our denominators are all the same, we can write it just one time underneath, x minus 3, x plus 3. All right, so let's look and see what is going to cancel out of the top and how we can simplify that. So I'm seeing a positive x squared and a negative x squared. I'm seeing a minus 3x and a plus 3x, a plus 1x and a minus 1x. Okay, and that might be it there. Let's see. So what does that leave me? That gives me an x squared plus 2x. It's going to take care of those two terms. And then I have a minus 3, and a minus 9. So that's going to be a minus 15. Okay, and this problem ends up being kind of lengthy because now when I look at what I've got, I see that I can probably factor what's on the top. So let's see if we can do that. So x and x, we can make 15 by doing 5 and 3. We want it to combine to make a positive 2, so we're going to keep the 5 positive since it's the bigger term and the 3 negative. And so again, now the x minus 3's will cancel. And we will end up with what we hope to be the final answer, x plus 5 over x plus 3. All right, our next example asks us to multiply or divide the rational expressions as indicated. So we want to start with our first one, which is x squared plus 3x minus 10 divided by x plus 3. times x plus x minus 3 over x squared minus x minus 2. So again, we want to go ahead and we want to factor those two quadratics to see if anything's going to cancel out. We'll have on the x squared plus 3x minus 10, x and x. We'll make the 10 with a 5 times a 2. We want a positive 3x, so we'll make the 5 positive, the 2 negative. For our denominator on the second fraction, we have x squared minus x minus 2, has to be x and x, has to be 2 and 1. We want the bigger term to be negative so that we have a negative 1. All right, so we're looking now for anything that can cancel. I'm seeing an x minus 2 in the top and in the bottom. Remember, this is multiplication, which is going to be totally different than an addition or subtraction. On an addition and subtraction, you're going to need a common denominator. On a multiplication, you're not. So if you're multiplying and you have a term in the top that you also have in the bottom, they can cancel out. And so we are going to be left with here x plus 5 times x minus 3 over x plus 3 times x plus 1. And that will finish up that problem for us. So that's a multiplication problem. All right, and one more. Let's do a division problem. We have x squared plus 5x minus 14 divided by 3x divided by x squared minus 4x plus 4 over 9x cubed. Now remember that when we're dealing with fractions, we cannot divide fractions. So instead, our rule is to write the first fraction down as it is. So x squared plus 5x minus 14 over 3x, and multiply by the reciprocal of the second fraction. So we're multiplying by 9x cubed divided by. So now that we have it set up, we want to go ahead and factor the top, or factor both of the quadratics. So let's do that. So the x squared plus 5x minus 14, we'll have x and x. For the 14, we'll do 7 and 2. We want the middle term to be positive, so we'll make the larger one positive, the smaller one negative. On the other one, x squared minus 4x plus 4, we're going to use x and x. We're going to do 2 and 2, okay? And we want the positive 4, so we either need them both to be negative or both of them to be positive. The middle term indicates they both need to be negative. All right, so now let's look at what cancels here. We have an x minus 2 that cancels. We also can reduce the 3 and the 9. 3 goes into 3 once, 3 goes into 9 3 times. We also can reduce this x in the denominator with one of the x's in the top. So that x is going to cancel with one of those, leaving me an x squared in the top. So we have 3x squared times x plus 7 left in the numerator. And we have an x minus 2 left in the denominator.